Welcome to the deep dive. Today, we're going to be diving into some really cool research about AI navigation.
Okay.
Imagine like a robot that can like understand and follow instructions,
Mm-hmm.
not just like, go to the kitchen,
Right.
but like more complex stuff like turn left at the blue couch, then right at the doorway.
Yeah.
We've got some research excerpts to unpack,
Okay.
focusing on a paper that's trying to make these AI agents much more versatile.
It's a pretty big challenge
Yeah,
because it's not just about like recognizing objects.
right.
The AI has to understand spatial relationships,
Okay.
the order of actions,
Right.
and even the intent behind the instructions.
Okay, so let's set the stage.
Sure.
The researchers break down these instructions into three levels of complexity:
Okay.
fine-grained, coarse-grained, and zero-grained.
Right.
Fine-grained being those detailed step-by-step commands.
Right. Think of it like teaching someone to cook.
Okay.
Fine-grained instructions are like following a precise recipe.
Mm-hmm.
You're told exactly what to do at each step.
Yeah.
But what if you want to create something new?
Right.
Improvise based on what's in your fridge.
That's where the limitations come in, right?
Yeah.
Just training an AI on those detailed instructions doesn't make it a master chef.
Exactly. It can follow the steps,
Right.
but it doesn't understand the underlying goal.
Okay.
So coarse-grained instructions like find the coffee mug in the living room
Mm-hmm.
require a different kind of thinking.
Yeah.
The AI has to figure out its own path, maybe even explore a bit,
Okay.
and then zero-grained is the simplest.
Right.
Just the object itself as the target.
So the question is, how do you build an AI that can handle all these instruction types?
Well, one might think just mix up all those different types of instructions during training.
Mm-hmm.
Let the AI figure it out.
Right.
But the research shows that just jumbling everything together
Yeah.
doesn't really work.
Because the goals of each type of instruction can clash, right?
Yes. It's like trying to learn how to play a musical instrument.
Yep.
By listening to a symphony, a jazz solo, and a rock concert all at the same time,
Oh, yeah.
the AI gets confused about what it's supposed to be learning.
So how did the researchers in this paper crack this problem?
They developed a system called SAMI,
Okay.
State Adaptive Mixture of Experts.
That's a mouthful.
It is a mouthful,
Hmm.
but the concept is really clever.
Okay.
Imagine the AI has a team of specialized experts,
Okay.
each good at a specific type of navigation.
So like one expert is the recipe follower, another is the freestyle chef,
Yeah.
and another knows the pantry like the back of their hand.
You got it. Now, Sammy is the manager of this team.
Okay.
It looks at what the AI, sees what the instructions are, and decides which expert has the best skills for that particular moment.
So it's not just blindly following instructions.
Right.
It's making decisions based on context.
Yes.
How does it do that?
Sammy relies on the AI's state,
Okay.
which is a combination of the current visual input
Mm-hmm.
and the instructions it has received.
Okay.
This state becomes Samby's cheat sheet.
Okay. It tells SAME which expert has the best skills to tackle the current situation.
So did they get good results with this Samba system?
The results are pretty impressive.
Okay.
SAME either matches or even beats AI models that are specifically trained for just one type of navigation task.
Wow.
And this is across a variety of benchmarks.
It's not just memorizing, it's actually learning and adapting.
Exactly.
Wow.
It's starting to generalize its knowledge,
Right.
which is a big deal for AI.
Yeah.
You want it to be able to handle new situations it hasn't seen before.
Right.
It performed especially well on a benchmark called Reverie,
Okay.
where the AI has to explore and follow instructions to find specific objects.
That's like the ultimate test, right?
Yeah.
Combining exploration, understanding instructions, and recognizing objects.
Pretty much.
So they basically gave the AI a virtual scavenger hunt.
Pretty much. And it managed to find its way.
Now, I'm curious about this mixture of experts concept.
Okay.
How does that actually work, especially when it comes to what the AI is seeing? That's one of the most fascinating parts.
Okay.
They applied this concept to the AI's visual queries.
Okay.
Think of it like giving the AI different lenses to look through.
Okay, so it's not just taking in everything it sees.
Right.
It's focusing its attention based on what's important for the task at hand.
Exactly.
Like if I'm looking for my keys, I'm not going to be paying close attention to the color of the curtains, right?
Exactly.
Yeah, okay.
SameWe helps the AI choose the right lens for the situation,
Right.
so it can filter out distractions and focus on what's important for making its next move.
So it's not just about seeing everything, it's about seeing the right things at the right time.
Exactly.
Now, I'm wondering, did they just like throw SAME into these virtual environments and hope for the best? Or was there some strategy to how they trained it?
They actually tried a few different training methods.
Okay.
One that stood out was called Dagger.
Okay.
Data set aggregation.
Okay.
It's like learning from your mistakes.
So instead of giving the AI perfect instructions every time,
Yeah.
they let it make mistakes and then learn from them.
Exactly. It's a more realistic way to learn.
Right.
And it actually led to significant improvements in SAM's performance.
Which makes you wonder, how does this dagger technique translate to the different types of navigation tasks?
That's a great question. And it leads us to some of the more nuanced findings of this research.
Okay.
They discovered that the order in which they introduced those fine-grained, coarse-grained, and zero-grained tasks to the AI
Right.
actually mattered a lot.
Okay, so instead of just mixing all the training data together, they found that a more structured approach was better.
Exactly.
Interesting.
It's almost like teaching a child.
Mm-hmm.
You wouldn't teach them algebra before they understand basic arithmetic.
Right. Right.
They found that a sequential approach,
Okay.
focusing on one type of task at a time,
Okay.
allowed Sam to build a stronger foundation of knowledge.
So it's not just about the quality of the data, it's about the order and structure of how it's presented.
Right. And this highlights the importance of carefully designing the training process for AI.
This has already given me a lot to think about, but before we get too deep into the training specifics, I'm curious about the data sets they used to test SAM's skills.
Okay.
What kind of virtual environments did they put it through?
They used a variety of benchmarks
Okay.
that are commonly used in AI navigation research.
Okay.
Some involve navigating virtual rooms based on fairly complex instructions.
Right.
Others focused on finding specific objects in simulated apartments.
So they covered a range of scenarios to see how SAM performed under different conditions.
Exactly.
And to really push the boundaries, they even tested SAM on data sets based on 3D scans of real-world apartments.
That's right.
Wait, so AI was navigating through virtual versions of real places?
That's right.
Oh, wow.
They wanted to see how well SAM's skills would transfer to environments that were more realistic and complex.
Now it's what I call a deep dive. And we're just getting started. Listeners, stay tuned as we explore what these findings mean for the future of AI
Right.
and how SAM could be applied to real-world scenarios.
So we've seen SAME excel in these virtual worlds, but the real question is, can it handle the messiness and unpredictability of the real world?
Right, because a virtual apartment is one thing, but imagine a robot trying to navigate like a crowded street or a busy shopping mall.
Yeah.
There are people moving around, obstacles popping up, unexpected noises.
Yeah.
It's a whole different ballgame.
That's the ultimate goal, isn't it?
Yeah.
They have robots that can seamlessly integrate into our world.
Right.
And while this research didn't involve like physical robots,
Right.
they did take some steps to bridge that gap.
Okay, tell me more about that.
Okay.
How did they test SAME's ability to deal with like a more realistic environment?
Remember those data sets we mentioned, like R2R,
Yeah.
with those virtual rooms?
Yeah.
Well, they also used a data set called R2RCE,
Okay.
which stands for Continuous Environments. It's basically like a souped-up version of R2R,
Okay.
but the AI has to navigate in a much smoother, more fluid way.
So it's not just jumping from one point to another in a virtual grid, it's moving more like a physical robot would.
Exactly.
Okay.
It has to deal with things like inertia turning radius,
Yeah,
things that you wouldn't necessarily have to worry about in a more simplified virtual environment.
right.
And Stamia handled this transition pretty well.
That's encouraging. But were there any tests that involved actual real-world data?
Yes. They used a data set called OBJECT-AV-MP3D.
Okay.
Now, this one is based on 3D scans of real apartments.
Oh, wow. So they're taking those incredibly detailed scans you see in like real estate listings
Yeah.
and turning them into a training ground for the AI.
That's right.
That's cool.
So in this data set, the AI is navigating through like a virtual replica of a real place.
Okay.
And again, Sam performed well,
Okay.
suggesting that its approach isn't just limited to those idealized virtual worlds.
Right.
It shows promise for real-world applications.
Yeah, it's exciting to see research moving in this direction,
Mhm.
but let's be realistic for a moment. What are some of the big hurdles they still need to overcome before we have robots zipping around our homes fetching our snacks?
Well, the real world is messy and unpredictable.
Yeah.
You have things like changing lighting conditions,
Yeah.
unexpected obstacles, people walking in front of you, a
Right.
million things that can throw off a robot's navigation.
Yeah, it's like the difference between playing a racing video game and driving in actual traffic.
Yeah,
The game is predictable, the real world, not so much.
exactly. In a simulation, you have a controlled environment.
Right.
In the real world, anything can happen.
And you can't really program a robot for every possible scenario, can you?
Not really. That's why adaptability is so important.
Right.
You need AI that can learn and adjust on the fly.
Okay.
And of course, there's the whole issue of safety.
Right. A robot bumping into a wall in a virtual world is one thing,
Right.
but bumping into a person or a fragile object in the real world is a completely different story. Exactly.
Safety is paramount, especially when you're talking about robots interacting with humans in shared spaces.
So while SAME is showing a lot of promise, we're not quite at the Jetsons level of robot helpers just yet.
Not yet. But research like this is paving the way.
Okay.
The insights from this paper, particularly this idea of a state-adaptive mixture of experts,
Right.
could be a game changer for real-world AI navigation.
Yeah.
It's about building systems that are robust, adaptable, and above all, safe.
Okay, so let's talk about the future. What are some of the potential real-world applications that get you excited? I'm picturing robot butlers serving us cocktails.
That might be a bit further down the line.
Okay.
But more realistically, think about things like household robots
Okay.
that can actually help with chores.
Right.
Imagine a robot that can tidy up, do laundry,
Yeah.
maybe even prepare simple meals.
I would definitely sign up for a robot chef. Or even just one that can fold fitted sheets properly.
But what about applications beyond our homes?
Right.
Think about delivery robots that can navigate complex urban environments,
Okay.
bringing packages right to your doorstep.
Yeah.
Or robots that can assist in search and rescue missions,
Okay.
going into dangerous areas to locate survivors.
That's a really powerful application, using robots to help in situations that are too dangerous for humans.
Exactly. Or even space exploration.
Okay.
Robots that can autonomously explore other planets, collecting data,
Yeah.
and maybe even setting up habitats for future human missions.
The possibilities really are endless. Now, we've been focusing on SAME and the technical aspects, but I'm curious about the human element behind this research. What can you tell us about the team that made this breakthrough?
The paper lists a team of researchers from several different institutions,
Okay.
a real collaboration of experts from various fields.
Right.
And that's often how the most innovative research happens, by bringing together different perspectives and areas of expertise.
Yeah.
It's like building that dream team of AI experts, but with real people.
It makes you wonder, what were those brainstorming sessions like? What sparked this idea of combining different experts within the AI itself?
It's fascinating to think about the process behind these groundbreaking discoveries.
Yeah.
What were those aha moments that led them down this path?
Right.
We often focus on the results, but the journey of scientific discovery is just as compelling.
And speaking of journeys, listeners, we're about to embark on the final leg of our deep dive.
Okay.
We've explored the what and the why of SAME,
Right.
but now it's time to delve into the how,
Okay.
the specific findings and insights that could shape the future of AI navigation.
Okay.
Stay with us. Welcome back to the deep dive.
Okay.
We're in the final stretch of our exploration of SAM,
Right.
this system that's making waves in the world of AI navigation. We've talked about how it works.
Right.
Its potential to revolutionize everything from household chores to space exploration.
Mm-hmm.
Now let's dig into some of the specific findings that really jumped out from the research.
One of the things that really struck me was how well SAME performed compared to other AI models.
Okay.
Remember we talked about those different types of navigation tasks? Fine-grained, coarse-grained, zero-grained.
Yeah, the different levels of instruction complexity.
Yeah.
It's like the difference between following a recipe step by step versus just knowing you need to end up with dinner on the table.
Exactly. Well, SAME was either on par with
Wow.
or even better than AI models that were specifically trained for just one of those task types.
So it's not just a jack of all trades, it's a master of all trades, which is kind of mind-blowing when you think about it.
It really is. It suggests that SAME isn't just memorizing specific instructions or routes.
Right.
It's learning to generalize. It's developing a deeper understanding of navigation itself,
Yeah.
which allows it to adapt to different situations.
And that's what we want in AI, right? Systems that can learn and adapt, not just follow pre-programmed rules.
Absolutely. That adaptability is key for navigating the complexities of the real world. Another finding that I found quite interesting was the importance of pre-training.
We touched on that earlier. It's like giving the AI a head start, right? Some basic knowledge to build on.
Exactly.
Yeah.
The researchers found that initializing SAME with a model that had already been trained on massive amounts of images and text
Yeah.
gave it a significant performance boost across all the navigation tasks.
So it's like saying, okay, You already know what a couch is and what turn left means, and now let's focus on how to use that knowledge to get from point A to point B.
That's a great analogy. It highlights the value of leveraging existing knowledge
Right.
to accelerate learning in AI. And speaking of learning, the research also dug into different training methods,
Yeah.
how they actually taught SAME to navigate.
We talked about that dagger technique where the AI learns from its own mistakes, which seems like a more natural way to learn. Honestly, we humans don't always get things right on the first try.
Exactly. Trial and error is a big part of learning. And the research showed that Dagger was a really effective training method for SAM.
But they also experimented with different ways of structuring the training data, right?
Yeah.
Like the order in which they presented the different types of navigation tasks.
Yes, that was another key finding. They tried two approaches,
Okay.
mixing all the data together in each training batch
Okay.
versus training on one task at a time sequentially.
So it's like deciding whether to study all your subjects at once or focus on one at a time.
And surprisingly, they found that the sequential approach worked much better for SAM.
Really? Why do you think that is?
It seems that mixing all the data together created too much conflict between the learning objectives of the different tasks. It was too much for the AI to handle all at once.
It's like trying to juggle too many balls at the same time, you end up dropping them all.
Exactly, by focusing on one task at a time.
Right?
SAM could develop a clearer understanding of each navigation skill before moving on to the next.
So it's a lesson in the importance of structured learning, even for AI breaking down complex tasks into smaller, more manageable chunks.
It makes you wonder if this principle could be applying to other areas of AI development. Maybe it's not always about bigger and faster,
Yeah.
but about smarter and more focused training.
Now, we've talked a lot about how SAME excels at handling different types of instructions, but one of the things that really sets this research apart is how they applied the mixture of experts concept to the AI's visual attention.
Right, we talked about those visual queries and how SAME helps the AI choose the right lens to look through. That's where the real magic happens.
It's like giving the AI a superpower, the ability to focus its attention on what's truly important in any given moment.
By applying the mixture of experts to the visual queries,
Right.
SAME enables the AI to dynamically adjust its focus based on the situation and the instructions. It's not just passively processing everything it sees,
Right.
it's actively selecting what to pay attention to.
Like a seasoned detective scanning a crime scene for clues.
Yep.
Exactly. It's filtering out distractions and zeroing in on the information that's crucial for making the right navigation decisions. And the selective attention seems to be a key factor in SAME's success.
Huh.
It's another step towards building AI systems that are not just reactive, but proactive and intelligent.
This whole deep dive has been a fascinating exploration. We've gone from the technical details of SAME to its potential to reshape industries and even explore other planets.
Yeah.
It's really been a journey through the cutting edge of AI research.
And it highlights the incredible pace of innovation in this field.
Yeah.
Who knows what breakthroughs are just around the corner?
Well, listeners, that wraps up our deep dive into the world of AI navigation and the remarkable SAME system. We hope you've enjoyed this journey as much as we have.
And as always, we encourage you to keep exploring, keep learning,
Right.
and keep asking questions about the ever-evolving world of artificial intelligence.
Until next time, keep diving deep.